Okay, we have here a really interesting looking integral. We're looking at an integral from -1 to infinity of e to the minus x squared minus 2x minus 2 dx. And just to be clear, this whole thing here, this polynomial is the exponent on e. And what I want to do before we do anything, we have a squared term here, and what I want to do is just notice the similarity to the Gaussian integral. Okay, we have our Gaussian integral here over on the right, and then when we have something in this form, our answer is just going to be square root of pi. The second formula, it really just comes out of this because this is an even function. So with an even function and the symmetric bounds, you could rewrite this as 2 times this integral, but then you divide by the 2 and you get this formula. So then my strategy, whenever I have something like this, is I want to kind of try to manipulate it so I can get it where I can use one of these formulas. It looks like we're heading towards 0 here, so it's probably going to be the second one, but let's see how it goes. So my first step is just going to take this whole exponent over here and manipulate it. And what I can do is, let's just factor a minus out, because we're going to want the minus on this, however we manipulate it, we're going to still want a minus in front. So we'll factor out a minus, and we're going to have x squared plus 2x plus 2. And then on this thing, what I'm going to do is complete the square. So I'm going to have, if I look at x plus 1 squared, so distributing this out, we'll have x squared plus 2x plus 1. We'll leave a 2 there. So if we just add another 1, notice that this is the same as this. Okay, and then what we'll do, we'll just distribute this minus sign in here. So we're going to have minus x plus 1 squared minus 1. And so what I'll do is we'll take this and we'll put this in the exponent, we'll rewrite the integral. From here, it's starting to look like what we want, but I think the problem is we have this negative 1 over here. Now using exponent properties, we could rewrite this thing. We could write it as e to the minus x plus 1 squared times e to the minus 1, separating that out. But then this is just a constant value, and we can bring it in front of the integral. So let's do that and see what we have. And I'll write this as 1 over e, because that's the same thing as e to the negative 1. So we're going to have, so we'll have our integral from -1 to infinity, and now we have e minus x plus 1 squared dx. And now to get it into this form, all we need to do is a u substitution, I think. So let's do, I'm going to do u, and we'll call our u that. So let's say our u is x plus 1. Well, that's pretty convenient because then du is just dx. So let's make this substitution and see what happens. We're going to have our 1 over e in front. And plugging infinity in here is still infinity. Minus 1 in here gives 0. We like that. This is our u, so we have e to the minus u squared du. And that's perfect. This is exactly our second formula. So then finishing it off, we're going to have our 1 over e times just this thing here. So we're going to have square root of pi over 2. And I'll just clean it up a little bit so it's nicer to look at. Square root of pi over 2e. That's it. I got this problem for my quiz, Gaussian integrals. I'll provide a link in the description. Thanks for watching. Please like and subscribe. Have a good day. Oh.